Okay, I have this polynomial, and the polynomial looks something like the following. It looks like x squared plus something plus 9. Now, how do I make this a perfect square? What value do I need to put in here to make it a perfect square? Pause the video and see if you can figure that out. Okay, if you've tried and you're not sure what to do, just think about it like this. If it was a perfect square, then I could convert it to a binomial squared, correct? We don't know what this value is yet, correct? So what would the first value be? It would be the square root of x, which is x. Sorry, it'd be the square root of x squared, which is x. And the second value would be the square root of 9, which is 3. And this plus, because it's plus over here, I know that it is a plus over here. Okay, so if that's the case, how do we expand that again? Well, that's just x squared. Remember the formula? A plus b squared equals a squared, which would be x squared, plus 2ab plus b squared. B squared would be, b squared corresponds to the 9, b corresponds to 3. A corresponds to x, a equals x. Or a squared corresponds to x squared. So then if, a equals x. So if 2ab, where do I get a from? A is x, b is 3. So 2 times x, 2 times x times 3, which is equal to 6x. So guess what's in the middle? 6x. Okay, let's erase all of this. And let's ask the question. If I asked you to graph this, would you know how to do it? And the question becomes, the answer is probably not. At this stage, no. Why? Because you don't know where the vertex is. None of these values give a vertex. None of these values give a vertical shift or an amplification or any of that. But try and think to yourself, can I graph it? Keep in mind what we just did. We just converted it. Can you graph it? Pause and see if you can do it. Okay, by now you may have thought about it, and you may or may not have solved it. Remember when we converted this? This was a perfect square trinomial. Because this is a perfect square, this is a perfect square. And the square root of this and the square root of that is basically 3x. And 2 times 3x is 6x. That's how we know it's a perfect square. So we know we can convert that to a perfect square. So if these two are the same, if these two values are the same equation, then we basically know how to graph this. Because if these are the same, then I just have to shift the vertex 3 spots. Step pattern 1, 3, 5, 7. 1, 3, 5. And we have our parabola. All right. Now I want to ask you something. Can you graph the following? Y equals x squared plus 6x. Oh, we already did that. We can just say minus 6x plus 9. Y equals x squared plus 24x plus 144. Y equals x squared minus... Now I have to build this backwards, right? I have to say, because I'm trying to build a perfect square, I have to say, so someone else guessed 36 in class earlier today. Divide that by square root. That is 6 times 2 is 12x. See if you can graph these. These are perfect squares. Okay, let's do this guy. This is actually a perfect square trinomial. It's equal to x squared minus... Sorry, not x squared minus. It's x minus 3 squared. This is the square root of this is x. The square root of that is 12. 2 times 12, x is 24, so it's a perfect square. So I can say x plus 12 squared. Here is the square root of 36 is 6. The square root of x is x. If you divide, if you multiply 6x times 2, do you get 12x? Yes, you do. And this minus shows itself there. It's part of our formula. So now I have 3 equations. I could actually graph this. If my trinomial is a perfect square, I know how to graph it, right? X minus 3, it's basically here. That's x minus 3. We should do that in a different color. This is x plus 12. It's all the way over here. Do our step pattern. That's 1, 3, 5, 16, or sorry, 7, 9 plus. And of course we have y equals x minus 6, so that's over here. Let's do it in yellow. It shifts to the right, sorry, to the positive direction. 3, 3, 5, 7. Anyway, that's a little messy, but that's all I have for you today, for now.